What happened before the Big Bang?
That's the most difficult question. Today, with the Hubble telescope, we can see more than 100 billion galaxies and in each of them perhaps hundreds of billions of stars.
But how did this happen?
Why is there something and why isn't there not nothing? This question is a big problem for many religions. It seems that someone had to create a universe as big as it is. As all of this can't happen of nothing. If you like our videos, please give us a thumbs up. Subscribe to Simply Space. Get excited about the videos that will be waiting for you in the future.
Let us begin the journey through the vastness of the universe.
Music. Applause. In 1926, Edwin Hubble found out that our galaxy is not the only one in the universe. And after another 3 years, he discovered that other galaxies were moving away from us. After this surprising discovery, it immediately seemed that we were at the center of the universe. But Hubble's observations suggest otherwise. The universe is expanding no matter which galaxy you observe it from. Everything that surrounds us has a past. Humanity, the flora and fauna, the atmosphere and oceans, the land and planet Earth itself. The sun is slightly older than the Earth, and the galaxy is much older than the sun. So both the Earth and the sun have their own past. So does the galaxy that appeared about 10 to 12 billion years ago. When people first heard about the Big Bang, they thought, what happened here? At first, this is a simple question that can be asked by anyone. In reality, however, this is perhaps the most difficult question. And so far, nobody has been able to answer it unequivocally. This situation did not suit scientists, of course, because they were used to finding answers to different questions sooner or later, even very difficult ones. The researchers received not one but a whole series of answers which were extremely strange and incomprehensible for normal people. An outstanding event in the history of the universe. The main answer was that there was nothing at all before the Big Bang. It turns out that the universe emerged out of nothing, meaning that everything came from nothing. It is impossible to imagine when and why this could happen. Everyone will say that not only can you not create a universe from nothing, but you can't even make a stool out of nothing. It is also possible that there were forms of substance in the mysterious nothing that were familiar to us. But it was not completely empty, and there were some processes that could lead to small explosions and eventually to the Big Bang. To find confirmation of this hypothesis, researchers are trying to create something similar to nothing. They've built special chambers from which matter particles were removed, lowered the temperature, and almost reached the cold of space. It turned out that the resulting nothing actually represents something and can be explored in various ways. Opponents of the hypothesis. Opponents of this hypothesis answer the question of what happened before the Big Bang in very different ways. However, the main idea is that the Big Bang is an outstanding event in the history of the universe, but the universe existed before that. So far, little can be said about what this ancestor of our universe was like, but it can be assumed that something happened in its history that led to the Big Bang that created our universe.
Many agree.
Of course, there are other opinions too. Maybe there was a universe before the Big Bang that was similar to ours. Or maybe not similar at all. We can also assume that before our universe, there were at least 2 other universes whose collisions led to the Big Bang. Finally, it can be assumed, and many also agree, that a truly incredible event took place in the first moment of our universe's history. The newborn universe swelled rapidly to enormous sizes, creating bubbles from which different universes grew one after another. This is how the great universe, also known as the mega-world or multiverse, came into being. If this is true, just as our galaxy is one of the billions of galaxies known to us today, our universe is one of many other universes that are completely unknown to us. Let us imagine that other universes are identical or similar to ours, made up of many galaxies, stars and planets. There are so many planets that in some of them there is intelligent life. Their inhabitants reached a very high level of development and became masters of their galaxy. Of course, they learned to fly from their planets to distant stars around which planets move just like our planet moves around the sun. Gradually, they also mastered many planetary systems in their galaxy and then of course met local aliens. Everything can be completely different if there are universes in the grand universe that are completely different from ours. Even science fiction authors find it difficult to imagine what is going on in these universes, and if there is life in them, what it is, what it looks like, and what actions its inhabitants are capable of. Obviously, not all people believe in the Big Bang and Darwin's theory of evolution. However, for most cosmologists and those close to this science, the Big Bang is already a generally accepted model for the early development of the universe. It is true that cosmology as a science was only defined in the first half of the 20th century. Before that, due to lack of evidence, many scientists had generated data at the level of speculation and unfounded theories. Important discoveries in cosmology such as the solutions and Einstein's equation that led physicists to the idea of singularity, the displacement of galaxies discovered by Edwin Hubble, and finally the Big Bang were discovered less than 100 years ago. In the last 50 years, modern studies on relic radiation, the formation of the structure of the universe, dark matter, etc. have been carried out, confirming and extending earlier developments. And this year, the physicist James Peoples received the Nobel Prize for this. The most important proof of the Big Bang and the expansion of the universe was the discovery of relic radiation, the microwave background that remained of the substance that was created in the early stages of the creation of the universe. This radiation reveals hot and cold regions in the initial universe. Scientists studied the relic radiation, the processes of particle formation and propagation, and came to the conclusion about the Big Bang in its approximate time frame. The universe is now gradually expanding further. It is remarkable that the initial expansion of the universe and the Big Bang are not the final educational processes. According to scientists, the universe is now gradually expanding further. According to scientists, the density of matter in the universe is slightly higher than previously anticipated, and therefore gravity should prevail in the inflation model, which supposedly turned the entire space around us into a closed sphere. Opponents of this theory say that it is just an error in the calculations because the relic radiation is a huge amount of data that almost certainly cannot be decoded 100% accurately. If the authors of the study of the closed universe are right, this threatens not only the existing cosmological theories but also the laws of physics and geometry. It is not a fact that in the existing inflation theory of the universe, scientists have not yet considered exotic matter that would compensate for the effects of gravity and confirm that space is truly infinite. In the 1960s, the Americans Arnapins and Robert Wilson discovered cosmic microwave background radiation, or relic radiation. Radiation noise that fills the universe evenly. This showed that space is not absolutely dead and cold with zero readings for temperature and energy, but is filled with relic radiation that warms the room temperature to -270 degrees Celsius or -454 degrees Fahrenheit. This residual heat is evidence of the warmer state of the universe after the Big Bang. Among the questions that particularly worried cosmologists were, for example, the question of
the formation of a structure in the universe.
How and why galaxies and their clusters could form as a result of the Big Bang. How small fluctuations in the expansion process led to such complex structures that we are now observing. The second question, which is actually closely related to the first, concerns the properties of the relic radiation discovered in 1965 by the radio astronomers Arnapins and Robert Wilson. When it was discovered, theorists calculated what properties this radiation should have and what that says about the origin of the universe.
The age of the universe.
The Big Bang theory and later observations of the expanding universe allow us to calculate the age of the universe. If we calculate the time it takes for the universe to grow from a point to its current size at a certain rate of expansion called the Hubble constant, and also take into account its temperature, we can assume that the age of the universe is about 14 billion years plus or minus 1 billion. This conclusion is confirmed by astronomical observations of the oldest objects in the universe. These are mainly small stars with a low rate of combustion. However, they could not have formed earlier than 500 million years after the Big Bang. So, it is impossible to determine the age of the universe from them exactly. It is now estimated to be 13.8 billion years old. The Big Bang theory is more than just a simple description of the expansion of the universe from a tiny point to its current enormous size. A series of events that changed their initial state determined the structure of matter and the structure of the universe. And all of this happened in the time between the first insignificant fractions of a millisecond up to 1 minute after the Big Bang. Without going deep, we can assume that the universe was incredibly dense and hot in its early stages and a tiny ball of pure colossal energy. As it expanded and cooled, various states of matter, energy, and even forces of nature appeared. This process vaguely resembles the cooling of steam and its transformation into water and then into ice. Each stage leads to a change in the state of matter, gaseous, liquid, or solid. This is called phase transition. But in the early stages of the universe, the transitions were much stronger and we still know nothing about the initial stage from which they originated. 3 major milestones led to empirical evidence for the Big Bang. 3 observations that even if neither Einstein nor Lane had existed, we would have to admit for better or worse that the universe was dense and hot at the beginning.
These are the observations of the expansion of the universe made by Hubble.
These are observations of the cosmic microwave background. This corresponds to the observed diffusion of light elements hydrogen, helium, and lithium in the universe of the quantities that would occur in the first minutes of the history of the universe. Let us know which of these features and facts about the Big Bang were new to you and which ones you already knew. Share your opinion with us, as always, by using the comment function. Music.